Hello all, as promised, we are back again. Today I am going to tell you how to add two voltages using electronic circuit. That is, if you have two voltage as input, that is, if you 5 volt and 3 volt, we need output 8 volt. That is, the circuit should add these two voltages together. So this is the circuit I'm going to deal with to get output with the sum of input voltages. This is the popular circuit. It is called non-inverting summing amplifier. As you can see, we have given inputs to the non-inverting terminal, that is terminal 3. We have used this R1, R2 as 1K. So we are giving each of the two inputs in this fashion. So V1 is equal to 3 volt. We are giving it with the help of R1. Then V2 is equal to 2 volts, that is 1K. Then the output side, this is the feedback network consisting of R3 and R4. We have kept it as 1K. We will get to know why we have kept it as 1K each. So this is the op-amp is working at a 12 voltage. This circuit has some disadvantage, or you can say limitations. So limitations is the correct word for this. The circuit has limitations. Let me tell you how this circuit works. So this is the design. See, we are using superposition theorem to get the output voltage. That is, with the help of superposition, we can prove that output is sum of two inputs. So, with the help of superposition, we can see that at the input terminal 3, there are two voltages. One is 3 volt and 2 volts, and there are resistors. So, with V2 is equal to 0, with V2 equal to 0, that is that imagine that the 2 voltage source is not there. So the voltage at the terminal 3, where that node is in pink color. So what is the voltage due to the 3 voltage alone? So we get this Vi1, V1 into R upon R plus R. Since R1 equal to R2 equal to R equal to 1K. So Vi1 we get it as 3 by 2, 1.5. Similar way, ignore the 3 V1 voltage, that is 3 volts. So voltage at terminal 3, that's non-inverting due to the voltage source, that is 2 voltage alone. That is also 2 into 1 upon 1 plus 1. You can see here it is 2 by 2, 1. So the total output voltage will be V1 plus V2 upon 2. So here V1 plus V2 upon 2 is 3 by 2, 1.5, 2 by 2, 1.5. 3 plus 2, 5 by 2, 2.5. So this is the input at the terminal 3. So it is just 3 plus 2 is how much? 5 divided by 2, 2.5. So we didn't get 5. So we need to use R3 and R4 such that we get output as 5 volts. Since for non-inverting amplifier, the gain is 1 plus R3 upon R4. So designing R3 is equal to R4 will get us gain as 2. So the input is half the sum of two inputs. So we need gain to be 2 to get the output such that V is equal to V1 plus V2. So you can see here V is equal to 1 plus R3 upon R4 into V1 plus V2 upon 2. So keeping R3 is equal to R4, that is 1K, you can see it will get cancelled. That 2 in the denominator and 2 in the numerator will get cancelled. Output will be the sum of the inputs. Here we have taken input as 3 voltage, 2 voltage. These are two separate inputs. So output is 5 volts. You can see here the green line. Okay, coming to the limitations. See, as you can see in the circuit, the op-amp needs 12 voltage supply. So, how do you mean by this 12 voltage supply? It means that output of the op-amp will not exceed the supply voltage. So the maximum output it can give is very close to 12, because saturation voltage will be less than the supply voltage, at least by say zero point 0.5 or 1 volt. That depends on the design, the inside differential amplifier and all. Let's not get ahead of it. So this is 12 volts as the supply, so output voltage, maximum output will be 11 volt. So there is limitation in the circuit, but it works fine for the small inputs like say 5 and 3 volt or 5. So thank you. We'll come back soon with a new video.